Welcome back, everybody. Talking about expected utility in this particular video. So I already have our utility function that we've stated in our last video, that not all dollars are created equal. We don't receive dollars with happiness the same way from our first $1,000 to after we have $1 billion, our next thousand after that. So we have a function here. I am going to write out, this is our now expected utility. So instead of EV, this is our EU for these functions. And I'm going to lay out an example here with, let's get the function written out here first. I'm going to introduce you to a term. This is called the natural logarithm, so ln. And if we're working on a BA2 Plus calculator, you're going to see the ln right next to the 7 here. And I'll show you how to use that here in just a moment. But our utility function is utility of w is natural logarithm of w, which is our wealth. And then we can multiply this by probability of how long this will happen, how probability of this happening. So I'll show you this in just a moment. But what I want to do here is to show you the old American game show. It's called Deal or No Deal. So Deal or No Deal is you have a large number of briefcases and you kind of pare it down, and there are different values on the board that come off. And so we're going to assume in this simplified world that we are down to 2 suitcases. The one suitcase that is sitting right next to us, and the other suitcase that is next to a model in a dress. And then the 2 suitcases that we don't know which are which, of course, $1,000, and the other one is $200,000. The bank calls and they give us an offer. So this is option A. This is our deal. This is our no deal, and our deal from the bank is $50,000. Bank offers $50,000. So now we have a decision to make. And before we do that, can we all just assume that the 2 options here are 50-50? Now, in our world, hopefully we can all agree on this. If we're talking to a contestant, they might say, you know what? I've got number 15 here, and that's the shoe size of my grandma. And her birthday was also on the 15th. And so I'm going to assign a higher probability to this one, so if we can all agree that this is literally going to be 50-50, I'll be really happy. So 50% chance we have 1,000, and a 50% chance 200,000. If we're an expected value maximizer, I could already really clearly see expected value of just below is 100,000, which would make me take the uncertain opportunity over the $50,000. But we're not this time. We're expected utility. We understand $50,000 is going to change our life in a very good way. So why would we risk it? Well, we don't know. Maybe there's enough over here, and that's why we're going to run our expected utility function here with our natural logarithm. Okay, so here's how it looks. If I'm punching this into a calculator, I'm typing in 1,000, and then I hit the ln button. 1,000, and then the ln button, and it's going to spit out 3.4, 6.9, 6.91. And then we're going to multiply that by 50%. And that's when I get the 3.45. I'm going to do the same thing for the other option here, natural logarithm of 200,000. And that's going to give me 12.21 multiplied by 50%. And I get 6.10. And I'm going to add these together, and it's going to give me approximately 9.55. This is my expected utility of A. Oh, we're getting a little mathy here. Hang with me. Hang with me. Next, we're going to do the same thing. It is ln of natural logarithm of 50,000. And then that gives us 10.82. Now we become expected utility maximizers. And of course, 10.82 is greater than 9.55. And we are going to take the bank's offer. And so that's how we can use this expected utility function in order to make more reasonable real life decisions. If we wanted to take that one step further, we could say, what is my certainty equivalent? In other words, what would be the amount that I would be willing to be indifferent from based on my utility over here? So what we have is I would take, in order to take the natural logarithm back up, we're going to use a function called e to the x. E to the x. Now, it just happens to be on my BA2 Plus calculator right above the ln. So it is the second, I'll hit the second button, and then ln, which would give me the e to the x. And I'm going to type in e to the x. I'm going to type in 9.55 or whatever we had with our utility function. And then I type e to the x, and it'll give me $14,141.94. Now remember, from our first video, this is what we call certainty equivalent, or CE. And this would be our point of indifference. Anything over this amount, based on our function here, we would take the bank offer. Anything lower, we would play. And that looks like more or less what we would do in reasonable decision-making situations. What if this were the case and we could just leave it at that? We have no need for anything in behavioral finance. So that's where we are going to now really dive into. We had this set and we lived in this expected utility world very contently for a very long time. And then behavioral finance came out back in the 1970s, and we started to detect violations of expected utility. So follow me on to the next video. That's where we're going to go. We're going to dig into the 3 violations of expected utility, and that takes us right into the teeth of behavioral finance. Thanks. We'll see you on the next video.